Welcome to EduQuiz. Today we will discuss the topic trigonometric ratios of some specific angles, which comes under the chapter Introduction to Trigonometry. Now, in this chapter, the first topic was trigonometric ratios, how to write the trigonometric ratios, the main trigonometric, which are the main trigonometric ratios, etc. This second topic is trigonometric ratios of some specific angles. How to write the trigonometric ratios for some specific angles, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. First let us see how do we write the derivation of these trigonometric ratios of some specific angle, how to get the values, that we will see. Now here if you see, for 30 degree and 60 degree, for both the angles we will get from the same figure. In order to derive the values of trigonometric ratios for 30 degree and 60 degree, first we need to make an equilateral triangle. So ABC is an equilateral triangle. If in an equilateral triangle, we know that all the angles are equal and they are equal to 60 degree because the total angle inside a triangle is 180 degree. And equilateral triangle means all the sides are equal. So all the angles are equal. Each angle will be equal to 60 degree. So if you draw a median AD, this will be the perpendicular as well for an equilateral triangle. So AD is the median as well as the altitude for this triangle ABC. Now let us take each side as A units. So AB equal to A units, AC equal to A units and BC is also equal to A units. So if BC is A, then BD and DC each will be half of that, that is A by 2. So each of this measurement is A by 2. Similarly, this angle is 60 degree, angle B and angle C, but this AD, which is the median as well as the altitude, and it will be the angle bisected as well, because all these median, altitude and angle bisected, these all will coincide in the case of an equilateral triangle. So this angle will be 30 degree. Now you got a right triangle ADB, in which angle B is 60 degree and angle BAD, this angle is 30 degree. Now this hypotenuse is AB, which is A. Now the base is BD, which is A by 2. Now how to find out the altitude? Again we can use Pythagoras theorem. AD square is equal to A square minus A by 2 the whole square. Using Pythagoras theorem, if you use Pythagoras theorem, we will get that AD square is equal to AB square minus BD square, or AD is equal to under root of A square minus A by 2 the whole square. So AD square will come as 3A square by 4 and AD will come as root 3 by 2A. So this height will come as root 3 by 2A. Root 3 by 2A. Now from this right triangle, we will be able to write the values. Now what will be the values? Sine 60 degree. Sine 60 degree is equal to opposite side divided by hypotenuse. So root 3 by 2 divided by A, which is root 3 by 2 itself. Whereas sine 30 degree. Sine 30 degree is equal to the opposite side of 30 degree. Opposite side of 30 degree is this side, which is A by 2. A by 2 divided by A. A by 2 divided by A will be 1 by 2 only. So sine 30 degree is equal to, we get sine 30 degree is equal to 1 by 2 and sine 60 degree is equal to root 3 by 2. Similarly, we will be able to write the values for cos and tan. Cos 60 degree is adjacent divided by hypotenuse, that is a by 2 divided by a, which is a by 2 divided by a is 1 by 2. Then cos 30 degree is root 3 by 2, a divided by a, which is root 3 by 2. And tan ratio will be sine divided by cos. So tan 60 will be sine 60 divided by cos 60, and tan 30 will be equal to 30 degree will be equal to sine 30 degree divided by cos 30 degree. So using this equilateral triangle, we will be able to write the trigonometric ratios for the angles 30 degree and 60 degree. Now, for 45 degree, we can use another triangle. That means now we are making an isosceles right triangle. An isosceles right triangle. Isosceles right triangle means it is a right triangle as well as it is an isosceles triangle. So AB equal to BC. Now again, because these two sides are equals, so let us take each side as A unit. So this is A and this is also A. We can use Pythagoras theorem here. So AC square, the hypotenuse AC square will be equal to A square plus A square, that is 2A square. So AC will be equal to root of 2A square, which is root 2A. So now we have all the three sides. So sine 45 degree. Sine 45 degree is opposite side divided by hypotenuse. So A by root 2A, which is equal to 1 by root 2. Similarly, cos 45 degree, adjacent side, which is also equal to A. So A by root 2A, which is equal to 1 by root 2. And tan 45 degree is equal to opposite side divided by adjacent side. A by A is equal to 1. Once we get sine, cos and tan, the remaining, that means cosec will be the reciprocal of sine. So it will be root 2. Again, sec 45 degrees is the reciprocal of this, that is root 2 again. And cot 45 degrees is equal to 1. Then, so we got the trigonometric ratios for the angles 30 degree and 60 degree from the first equilateral triangle and 45 degree from this isosceles right triangle. Now, remaining 0 degree and 90 degree, sine 0 degree is equal to 0 and sine 90 degree is equal to 1. We will not be able to construct any triangle using one of the angles as 0 degree and one of the acute angle as 90 degree, because already one angle is 90 degree. So there cannot be two angles with 90 degree in a triangle. So we will not be able to construct a triangle. So you have to remember these values. Sine 0 degree equal to 0 and sine 90 degree is equal to 1. Then cos 0 degree is equal to 1 and cos 90 degree is equal to 0. So these are the values of trigonometric ratios for the angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now there is an easy method to remember these values. So we can see here there are values for some specific angles only, not for all the angles. Some specific angles only the values are given. Now these are the angles are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So if we check here, this table you can see this is given as a video, this and it is explained well in the video also. So in this there are angles written on the top 0, 30, 45 degree, 60 degree and 90 degree. First of all, what we do is corresponding to, and you can write sine theta, cos theta and tan theta like this as rows, and here for the columns on the top these angles. When we start writing the table, first we can start with 0 degree here as 0, this 1, 2, 3 and 4. Just we can write the value 0, 1, 2, 3 and 4. Next is dividing each number by 4. So 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. Then taking the root of these, which is written here, that is root of 0 by 4, the value is 0. Then root of 1 by 4, it is 1 by 2. Then root of 2 by 4, 2 by 4 means it is 1 by 2, root of it is 1 by root 2. Then root of 3 by 4 is root 3 divided by root 4, which is root 3 by 2. And 4 by 4, 1 and root of that is 1 itself. So easily we got the values of sine for these angles 0, 30 degree, 45 degree, 60 degree and 90 degree. Now for writing the values for cos, just reverse the order. So start with this 1. So this 1 will come front. That means starting with 1. Then this root 3 by 2 will come here, root 3 by 2. Then this will come as such, that is 1 by root 2. Then this 1 by 2 will come here, that is 1 by 2 here, and the 0 will go to the last column, that is 0. So writing the same values in the reverse order, we will be getting the values for cos. Now when we are writing for tan, just divide sine theta by cos theta. Like 0 divided by 1 is 0 divided by 1 is 0. Now how to write the remaining? So it is 1 by 2 divided by root 3 by 2. So this will come as 1 by root 3. Here 1 by root 2 divided by 1 by root 2, which is 1. Root 3 by 2 divided by 1 by 2, which is root 3. And here 1 divided by 0. 1 divided by 0 is not defined. So this tan 90 degree is not defined. Now, once we get the values for sine, cos and tan, just take the reciprocal. We will be able to write the values for the remaining trigonometric ratios, that is cosec, sec and cot. Now, we will see few problems related to this, how we can solve the problems from this particular section. Now, you will be getting for the examination, you will be getting the questions related to this as, right? For example, if you take like this, find the value of cosec square 45 degree plus tan square 45 degree minus 3 sine square 90 degree. The only one thing is, first you draw the table and write the values of these things, cosec 45, tan 45 and sine 90. Then we can just substitute in the question so that we will get the value. So like for cosec 45 degree, it is the reciprocal of sine 45. So sine 45 degree is 1 by root 2. So cosec 45 degree is equal to root 2. Tan 45 degree is 1 and sine 90 degree is 1. So just substitute here. So you will get it as root 2 square plus 1 square minus 3 multiplied by 1 square. That is 2 plus 1 minus 3, which is equal to 0. So it is very easy to do this type of problems. Next question is, find the value of x if cosec 3x is equal to cot 30 plus cot 60 divided by 1 plus cot 30 multiplied by cot 60. Here also, first thing we need to know the values of this. So tan 30 degree is equal to 1 by root 3. So cot 30 degree is the reciprocal of tan. So if tan is 1 by root 3, cot 30 degree will be equal to root 3. Then tan 60 degree is equal to root 3. So cot 60 degree is the reciprocal of that, that is 1 by root 3. If you know these two values, just substitute here. So this one, that is cot 30 degree plus cot 60 degree divided by 1 plus cot 30 degree into cot 60 degree will come like this. That is root 3 plus 1 by root 3 divided by 1 plus root 3 multiplied by 1 by root 3. When you do the simplification of this thing, take the LCM 3 plus 1 divided by root 3 and divide by here They get cancelled and you get 2. So on total, you will get it as 2 by root 3. Cosec 3x. On this side, it is cosec 3x. So cosec 3x is equal to 2 by root 3. So cosec is the reciprocal of sine. So sine 3x will be the reciprocal of this value, that is root 3 by 2. Now check for which angle sine ratio is coming root 3 by 2 in the table. From the table, we will get that sine 60 degree is equal to root 3 by 2. That means this 3x must be equal to 60 degree. Then only sine 60 degree will come as root 3 by 2. So 3x is equal to 60 degree. So x is equal to 60 divided by 3 is equal to 20. So the value of x is, it is solve for x or find the value of x for when this equation is true. So we will be getting the value of x as 20 degree. Now, one more question we will see. If A and B are two acute angles of a right triangle ABC, right angle at C, such that sine A plus B is equal to 1 and cos A minus B, right? You have to check that this is the total angle. It is not sine A plus sine B, it is sine of the angle A plus B is equal to 1 and cos of the angle A minus B, difference of the angles A and B, A minus B is equal to root 3 by 2. Find the measurements of angle A and angle B. So, how to find the solution of this? How to solve this? Sine A plus B is given as 1. But we know that sine 90 degrees is equal to 1. So, A plus B, in the place of A plus B, it must be 90 degrees. So, the first equation is A plus B equal to 90 degrees. Similarly, second one is cos A minus B is given as root 3 by 2. But we know that cos 30 degree is equal to root 3 by 2 from the table, trigonometric table. So A minus B, in the place of A minus B, 30 degree should come. That is A minus B equal to 30 degree. Now we got two equations and two unknowns. The unknowns are A and B. The variables you can take them A and B. So just add linear equation in two variables. So pair of linear equation in two variables. To solve it, we can just eliminate one. So just add them. If you add them, B and minus B cancel. So we get twice A is equal to 90 plus 30 is 120 degree and A is equal to 60 degree. And substituting this value of A in any of the equations, for example, first equation, we get 60 degree plus B equal to 90 degree. So B equal to 90 minus 60 is equal to 30 degree. So these are few types of questions that you may get from this particular section. And here you can see the quiz also. Values of cos ratio remain between what are the minimum value of cos is 0 and the maximum value of cos is 1. So 0 and 1. Value of tan remains between, actually the minimum value will come again as 0 and because it is 0 by 1, sine by cos is 0 by 1 and the maximum value is not defined. Not defined means it will go to any higher value. So we can say that positive infinity or 0 to not defined or positive infinity till infinity. Now the third one is, it is true or false. Sine 30 degree plus sine 60 degree equal to sine 90 degree equal to 1. Where it is true or false. Sine 90 degree is equal to 1. That is correct. But sine 30 degree plus sine 60 degree, the value of sine 30 degree is 1 by 2 and value of sine 60 degree is root 3 by 2. So sine 30 degree plus sine 60 degree will come as 1 by 2 plus root 3 by 2, which is equal to 1 plus root 3 divided by 2, which is not equal to sine 90 or equal to 1. So it is false. Similarly, here also, the next question also, sine 45 plus 45. This is sine 90 and sine 90 degree is equal to 1. Whereas this part, sine 45 plus sine 45, it is 1 by root 2 plus 1 by root 2, which is equal to 2 by root 2, which is equal to root 2 only. So again, this is also false. Now, the last one is if sine theta is equal to 1 by 2, what is the value of 3 cos theta minus 4 cos cube theta? So, if sine theta is equal to 1 by 2, then we know that sine 30 degree is equal to 1 by 2. So, this theta will come as 30 degree. Theta is equal to 30 degree. If theta is 30 degree, then cos theta will be cos 30 degree. That is root 3 by 2. Let's just substitute the value here. 3 cos theta minus 4 cos cube theta, that is 3 into root 3 by 2 minus 4 into root 3 by 2 the whole cube. So after simplification, we'll get like this, and which is equal to 0. So this way, we will be able to, this type of questions we will get from this particular section, and we will be able to solve the questions using this particular by applying the values of trigonometric ratios for some specific angles. Now, the last subtopic of this particular chapter is trigonometric identities, which we will discuss in the next session. So stay tuned to EduTips. Thank you.